Welcome back, Chemistry 30. This is the EQ1.5 section. So last video we looked at EQ1.4, heterogeneous equilibrium. Now we look at calculating equilibrium constants and manipulating it to find out concentrations, and also calculating equilibrium concentrations given the equilibrium constant, initial concentrations, and one equilibrium concentration. So this first video we'll just look at phase number 1 here, learning objective number 1, and then you'll be able to do the first question on the EQ1.5 assignment. Then we'll come back in another video or 2 videos and look up learning objective number 2, and then you'll be able to finish off the rest of the assignment. So in calculating the Kc, the equilibrium constant, and all but one equilibrium concentration is given, the unknown equilibrium concentration value can be found just simply by rearranging the equation and solving for the unknown. That's really what this is. So if I look over here, I have 2 examples, kind of one of each type that we'll be looking at. The equilibrium. So the key thing here is when you're doing a question like this, see what kind of concentration you're given, because earlier we talked about equilibrium concentrations versus initial ones. It's the equilibrium ones that go into the Kc or Keq expression. So we're told that the equilibrium concentrations of SO2 and O2 are each 0.0500. We know what the Kc is, the equilibrium constant, and calculate what SO3 would be. So to start this off, these are all equilibrium concentrations. So if we can find out the equilibrium, the Kc or the Keq equation, we'll be able to figure it out. So here I have 2 SO3s. So multiplying those 2 together, or we treat it as SO3 squared, all over SO2 squared O2. Okay, so we set it up like that initially. Kc, we know, 85.0. SO3, that's what we're asked to find out. And each of the SO2 and the O2, we are told, are each 0.0500. And this one is squared. Good. Now here, so we're looking for the numerator. So when solving for the numerator, if you recall from like earlier math classes, if we're looking for this, let's say, I don't know, let's say those are our numbers. If I'm looking for x squared divided by 3, multiply by 3, multiply by 3, and I'll end up with x squared equals 6. So here I do the same thing. I want to, now I'm going to rewrite it here just so we can see a difference between the two. Of course, you don't have to rewrite it like this, but I will just so that we can see that step happening in there. Use a different color. So multiply by the denominator. So we can see cancel, cancel, cancel. And we're left with SO3 squared is equal to all of this multiplied by each other. And so we're going to solve for SO3 squared. And just like here in earlier math classes, square root both sides, right? So square root each side, and I'll end up with SO3, the concentration of that, it's going to be equal to the square root of all of the left-hand side. So please run this through your calculator to make sure you're doing it right. So square root, and you could start bracket. Be careful with your square root button, because quite often if you type in square root, start bracket, then you have this part, 0.0500 end bracket squared. Then you start out another bracket. Your calculator is going to think that, oh, I'm just taking the square root of this and multiplying by the rest. So be careful. You may want to put an extra bracket in there just so your calculator is calculating the square root of the entire expression there. Okay, so be careful because your calculator sometimes will do that. Needless to say, what you get is an answer. Please check it with your calculator. 0.103. Now, since this is a molar concentration, we do have a unit. It's big M for molar. Okay, so please run that through your calculator to make sure you got that. Okay, on the next page we have another example. I know I have here you try, but we'll do this one together too, just because it's a little bit different. And this one we're solving for the denominator, I believe. The following reaction takes place. The equilibrium, the KEQ, is 1.78. If the equilibrium concentrations of PCl and Cl2 are both 0.85, and again, those are equilibrium, that's a key thing to note because when we do the second video, you'll see that sometimes we're given initial concentrations and those don't go in the equilibrium expression. So we know what PCl3 is and Cl2 is. Calculate PCl5. So we're looking for that. So again, set it up as per usual. KEQ equals products over reactant. So KEQ is 1.78. PCl3 and Cl2 are each this. And we're asked to find for PCl5. Now I'm going to go through how we solve that, rearrange that equation to solve for the denominator. And we can make it, think of an easier question such as this that you would have done in earlier math classes. Let's say 2 equals 6 divided by x, okay? So there's kind of a long way to do it and a short way to do it. So we have 2 equals 6 over x. So the unknown is on the denominator. What you usually want to do is bring that up to the numerator. So multiply the numerator by 6. Cancel, cancel. We'll have 2 times x equals 6. Then of course you can see divided by 2, divided by 2, x equals 6 over 2. X equals 6 over 2. So that's kind of the long way to do it, but if you take a look here, there's a shortcut. Shortcut there. So the mathematical shortcut here, 6 over x, 6 over 2, is just simply, now I hate to use these words, but cross multiplying is technically the kind of cheating way of which you would say that, but actually it's rearranging the equation and solving for the unknown. But you can see here we can just simply quote unquote switch the denominator with the answer on the opposite side. Okay, so that's kind of a shortcut we can do, and it is mathematically correct, but quite often you may have said, oh, we cross multiply, and yeah, it's kind of a shortcut way of saying rearranging and solving for a variable. So we can do that. So the concentration of PCl5 is equal to 0.85 multiplied by 0.85 divided by 1.78. So simply put that in your calculator and you should get 0.406. And of course this is a concentration, so we do need that molar unit there for this one, because we're not solving for KEQ, we're actually solving for a concentration. All right. Hey, so with that, you should be able to we'll stop the video there. You should be able to do the very first question in the assignment 1.5. And then in the next videos, we'll look at part 2, and you'll be able to finish off the rest of the assignment after that. All right, we'll see you again.